Okay, so we've done a lot of examples with finding reference angles. Now we're going to do some examples of using reference angles to evaluate trig functions. So that's really how reference angles are very useful, because you can only remember the trig functions, values of trig functions at a few specific special angles on the unit circle. If you remember the trig functions at these angles here, and just remember how reference angles work and how sines, SIGN sines of trig functions in the quadrants work, then you'll be good to go. Of course, there are various other ways of approaching problems that ask you to evaluate trig functions, but we've talked about some of those. We'll do some more later on. But anyway, let's go through an example here. So example 1, use reference angles to evaluate cosine of 7 pi over 6 and sine of 7 pi over 6. Okay? So how do we do that? How do we use reference angles to evaluate something? Well, there's a property here which is really great, really great, that says so let's say if alpha, okay, if some angle alpha is the reference angle, if alpha is the reference angle for a given angle theta, then what we have is cosine of theta equals plus or minus cosine of alpha. Where the sign, SIGN sign, okay, where this plus minus sign depends on which quadrant theta is in. Okay. And when we say which quadrant theta is in, what we really mean is which quadrant is the terminal side of theta in. Okay, so theta is an angle in standard position. It has a reference angle, and we're going to call this reference angle alpha just for the purpose of this discussion here. Okay, so what's true about angles and their reference angles is that if you evaluate a trig function at an angle and you evaluate a trig function at the reference angle, you're going to get the same value up to a sign change, okay, SIGN sign change. So now remember, reference angles are always acute, right? And trig functions of acute angles are always positive. So whatever is going on with alpha and theta, alpha is the reference angle, so it's acute. So cosine of alpha is always positive. Okay, so cosine of theta is going to be the same as cosine of alpha, or it'll be negative cosine of alpha, depending on which quadrant theta is in. Okay, because remember, if theta is in quadrant, okay, so let's draw our quadrants here. So remember, we talked about in an earlier video, if theta is in quadrant 1 or in quadrant 4, then the cosine of theta is positive. Okay, so if theta is in quadrant 2 or quadrant 3, then the cosine of theta is negative. Okay, so that's how you determine the sign, the SIGN sign of that, okay? Now, we express this statement here in terms of cosine, but it's actually true for all 6 trig functions. Okay, you can replace cosine with sine, SIN sine, or with tangent, or secant, or cosecant, or cotangent, and it's exactly the same. Okay, so that's what's so great about reference angles, is you can use them to simplify evaluating trig expressions. Okay, so here 7 pi over 6, it's not a terrible angle, right? It's one of the special ones on the unit circle, but we might be more likely to remember stuff about pi over 6 rather than 7 pi over 6. So remember, pi over 6 is the reference angle for 7 pi over 6. We did that in an earlier video, and actually we're going to use that fact in this video. We're not going to go through it again. So if you do want to see how we determined that pi over 6 is the reference angle for 7 pi over 6, check this video description. There will be a link to that video in there if you haven't seen that video. So anyway, we're going to use that fact that we established in that other video, and we'll do that for the next few examples also for this kind of thing. Okay, so anyway, so let's go ahead and get started here. So again, just to recap real quick, if alpha is a reference angle, is the reference angle for a given angle theta, then cosine of theta is the same as cosine of alpha up to a sine, SIGN, sign change, okay, meaning plus or minus cosine of alpha, where this sign, SIGN sign, depends on which quadrant theta is in. So remember, cosine of theta is going to be negative if theta is in quadrant 2 or quadrant 3. Okay? So for this specific example here, here's our theta. 7 pi over 6 is our theta. Okay, that's our theta. Now, again, I want to point out, since 7 pi over 6 is a special angle on the unit circle, yeah, we could just look at this and say, oh, well, isn't cosine the x-coordinate and sine is the y-coordinate? Yeah, that's true, but this is another way of doing it. So if you want, you could just remember these special values in the first quadrant and then apply reference angles and this rule about where are the trig functions positive and where are they negative and things like that. So just one more of many ways to approach problems that ask you to evaluate trig expressions. Okay, so let's get started with this then. So like we said, we established in an earlier video that the reference angle, okay, so the reference angle, which I'll abbreviate ref angle, for 7 pi over 6 is just pi over 6. Okay, so if we're thinking about this discussion here, 7 pi over 6 is our theta, and the reference angle pi over 6, that's our alpha here. Okay, so now we want to know what quadrant is theta in. So remember, if we were to draw this, so we actually just saw it on the unit circle sheet that we looked at, but we also know if you're not sure which quadrant that's in, you might want to keep track of stuff like that, just even if you don't memorize these values for these special angles. Definitely know which quadrant these are in, or there's various ways to think about it, which if you haven't seen the other examples for finding reference angles, check out those videos, and we talk about a few different ways of thinking about that. So anyway, 7 pi over 6 is over here. Okay, here's 7 pi over 6. Okay, so here's what we say then. Let's block this off up here. Okay, so 7 pi over 6 is in quadrant 3. Okay, so what does that mean? So cosine of 7 pi over 6 is negative, and sine of 7 pi over 6 is also negative. Right, so remember we talked about that. We talked about where the trig functions are positive and where they're negative. We talked about that in a separate video a while ago. So in the third quadrant, cosine is negative and sine is also negative. Okay, because remember cosine corresponds to the x-coordinate on the unit circle, right? And if you're in the third quadrant, the x-coordinate is negative. Sine corresponds to the y-coordinate, and if you're in the third quadrant, you're below the x-axis, so the y-coordinate is negative. So anyway, cosine of this is negative, sine of that is negative. So applying this rule up here for reference angles, what that tells us then is that, okay, well cosine of 7 pi over 6, okay, well actually if we apply this directly, then what we have is cosine of theta equals negative cosine of alpha, okay, in this case. And the same thing for sine. Sine of theta equals negative sine of alpha. Okay, so remember we also said that even though we wrote this in terms of cosine, it's true for all 6 trig functions. Cosine, sine, tangent, secant, cosecant, and cotangent. It's true for all 6 of them. Okay, so this is what we have here. Remember, for our specific problem, theta is 7 pi over 6, and alpha is our reference angle, pi over 6. Okay, here's our theta. Here's our theta, 7 pi over 6, and then here's our alpha, pi over 6, our reference angle. Okay, so what we've actually just found out here is that cosine of 7 pi over 6, it's the same as cosine of pi over 6 because that's how reference angles work. And since cosine of 7 pi over 6 is negative, because 7 pi over 6 is in the third quadrant, cosine of 7 pi over 6 is negative, so we have to put a minus sign out in front here, right? And that's how we get that. So then what we can do is say, okay, cosine of pi over 6, I know that that's root 3 over 2. Or if you're not sure about that, you can go back to the unit circle and say, oh, cosine is the x-coordinate, root 3 over 2. So it's going to be negative root 3 over 2. Okay, sine of 7 pi over 6, same exact thing, right? It's the same as sine of pi over 6, but what we found out just a minute ago is that it's actually going to be negative, okay? So it's the same thing as sine of pi over 6, but it's got a minus sign in front of it because 7 pi over 6 is in the third quadrant, therefore the sine of 7 pi over 6 is less than 0, okay? So we put a minus sign in front of it. So then sine of pi over 6 is 1/2, so we have minus 1/2, okay? So that's, you know, it might seem kind of complicated or kind of confusing. It's really not that bad. All you got to keep track of is, well, first you have to know how to find reference angles. And again, we glossed over that here because we did it for this exact angle in a different video. So again, check this video description for a link to that video. Anyway, then we use that fact to say, okay, well, since pi over 6 is the reference angle, then the trig functions at these two angles are the same up to a sine, SIGN sine change. And this sine, SIGN sine, depends on which quadrant theta is in. And our theta, 7 pi over 6, is in quadrant 3, so the cosine of theta and the sine of theta are both negative. That's why we have this minus sign here, okay? So again, always think about which quadrant theta is in. Don't think about the quadrant of alpha. Alpha is in quadrant 1 because it's acute, okay? Remember, alpha is a reference angle, so it's always acute, so it's always in quadrant 1. So just totally don't even think about that. Just think about what quadrant is theta in, okay? That's the key there. Okay, so that's example 1 with using reference angles to evaluate trig functions. So example 2 coming up in the next video.